Welcome back. In this session, we're going to look at volume and surface area. Now, the unit for volume is kilometers to the power of 3, meters to the power of 3, centimeters to the power of 3, or millimeters to the power of 3. The volume of a cube is given by the formula side times side times side, or side to the power of 3. The volume of a rectangular prism, L times B times H. Remember the matchbox? This was a rectangular prism. The volume of a triangular prism, that was the Toblerone chocolate, half base times height times the big height. I'll discuss that later. And then the volume of a cylinder, like a can of Coke, pi radius squared times height. And then the volume of any irregular figure. You get the area of the base times the height. Now, capacity. Remember, to convert from volume to capacity, there is something very important that you must remember. 1 cubic centimeter is equal to 1 milliliter. I'm going to show you what 1 milliliter looks like. I have this cube in my hand, and if you look at it, you will see this is 1 centimeter by 1 centimeter by 1 centimeter. And this gives me the volume of this cube is 1 cubic centimeter. And this is exactly 1 milliliter. So 1 cubic centimeter is equal to 1 milliliter. The easiest way to swap from volume to capacity is to get your answer in cubic centimeters. And then you can just take the answer and change it to milliliters, because it's exactly the same. Remember, this is 1 centimeter by 1 centimeter by 1 centimeter. 1 cubic centimeter is equal to 1 milliliter. Then 1,000 cubic centimeters is 1 liter. That means 10 by 10 by 10 by 10 is 1 liter. And then also 1 cubic meter is 1 kiloliter, if you have a sum with that. Normally they give you the dimensions or a reminder of this when you do the calculations. Now, important information: when working with perimeter, area, surface area and volume, formula will always be provided. Make sure that you write down the formula correctly and that you substitute correctly. The red light of when they give you diameter, you must go to radius. It is advisable to check your units before you substitute. If your units are not the same, start by converting all units to be the same. This is very, very important. You cannot work with different units in one sum. And then for compounded shapes, shapes made up of 2 or more different shapes. For instance, the perimeter, you add all the outer sides or the areas and the volumes, you add them together or subtract them. This is the one where I said you do it as you eat an elephant. And then surface area. I think surface area is one of the difficult ones, so please pay attention. The unit for surface area, I'm going to stress the word area, is kilometer square, meter square, centimeter square or millimeter square. The surface area of a cube is 6 times L times L, 6L square. The surface area of a rectangular prism is 2LB plus 2BH plus 2LH. The surface area of a cylinder is 2 pi radius square plus circumference of the circle times height. And then the surface area of a triangular prism, 2 times half base times height plus the perimeter of the triangle times height. Let's look into the surface areas more carefully. The nets of a solid, A net is a pattern made when the surface of a three-dimensional figure or a solid is laid out flat, showing each face of the figure. I will show you now. It is then possible to use the net to calculate the surface area of the solid. Let's start with a cube. As we said, the surface area of a cube is 6 times L times L, or 6L squared. A cube is a three-dimensional figure with 6 matching square faces. Please count those squares there. It's 1, 2, 3, 4, 5, 6. The following nets can be folded along the dotted lines to form a cube. That is how I made that cube. So the surface area of the cube is 6L squared. Next one, the surface area of a rectangular prism. A rectangular prism is given by the surface area of that rectangular prism is given by the formula 2LB plus 2BH plus 2LH. A rectangular prism is formed by folding as a net as shown. There you can see what it looks like. I want to draw you one here on my page. Just look here. If I unfold a rectangular prism, the shape that I will get looks like this. The base, then there's a shorter side there, and then the base will repeat, then the shorter side again, and then this side there and this one there. As you can see, this part and this one is exactly the same. There are 2 of those. That's why we say 2, this is the length, this is the breadth, 2LB. Plus, as you can see, there are 2 of these. 2 times, that is the length, times the height of the prism. Plus, look at the next one. This part and that part, there are 2 of those. That is the breadth. That is the breadth times the height there. And that's where we get the formula. 2 of those, and 2 of these ones. And now we go on to the next one. The surface area of the cylinder. The surface area of a cylinder is given by the formula 2 pi radius bracket radius plus height. And I want you to watch this video.
I want you to understand how exactly we find the formula for the surface area of a cylindrical solid. Here we see a cylinder, and what we're going to do is separate this cylinder into 3 parts, 3 places where we have a surface area: the top, the shell, and the bottom. And so here's the separation. If we unwrap the middle part of the cylinder, what we basically get is a rectangle and 2 circles. The area of each circle is pi r squared. And then this top edge of the rectangle is the same thing as the circumference of this cylinder. And so we have a formula for the circumference, and it must be the same as the length along the top of this rectangle. We have a height for the rectangle, and so the area of this rectangle is the length times the height, 2 pi r h. Putting those all together, we get that the surface area for a cylinder is pi r squared plus 2 pi rh plus pi r squared. More commonly, we write this as 2 pi r squared plus 2 pi rh.
The question concerning the surface area of a cylinder was asked last year, and the kids suffered with that question. You will see we will get to one of the questions concerning that, so I will discuss that again, what you've seen in the video. Now the next one is the surface area of a triangular prism using the net. As you can see, when I unfold the triangular prism, all the different sides that you get the 3 sides of the prism and then the 2 triangles. And the base, 2 times half base times height, means the 2 triangles. And then you get the perimeter of the triangle and you multiply it with the height. Now to convert. Conversion is a big problem in mathematical literacy. The best time to convert is before you start calculating. Don't try to calculate with different units and then you want to convert the answer. Convert before you even start. That is one of the red lights that must go up. Now when I convert from kilogram to gram, I must multiply with 1,000. To go from gram to milligram, I multiply with 1,000. When I go from kiloliter to liter, multiply with 1,000. Liter to milliliter, multiply with 1,000. But when I go backwards, I do the opposite calculation. Opposite of multiplication is division. So when I go from milligram to gram, I'm going to divide by 1,000. From gram to kilogram, divide by 1,000. To go from milliliter to liter, divide by 1,000. And divide with 1,000 when I go from liter to kiloliter. And the one that I really want to get to is the one where we convert from kilometers to meters to centimeters to millimeters. When I go from kilometers to meters, you must remember I times with 1,000. When I go from meters to centimeters, I always remember a century is 100 years. So then I will multiply with 100. Centimeters to millimeters is times 10. So I have 1,000, 110 for kilometers, meters, centimeters and millimeters. When I go in the opposite direction, I will do the opposite calculation. Millimeters to centimeters, divide by 10. Centimeters to meters, divide by 100. Meters to kilometers, divide by 1,000. Please write this down. Kilometers times 1,000 times to meters times 100. Centimeters times 10 to millimeters. And division when you go backwards. There were 3 questions that came in. The one question was, what is the difference between area and perimeter? Now, it's a big difference between the two. When I have, for instance, a swimming pool. This is my swimming pool and I want the perimeter. Then it means I want to put fencing around my swimming pool and that will be the perimeter. But when I want to tile my swimming pool with tiles and I put tiles throughout the whole swimming pool, then it will be area. So this is the area of the swimming pool and the red line is the perimeter of the swimming pool. Let's put in some distances. Let's say the swimming pool is 10 meters long and 3 meters wide. So the perimeter will be 10 plus 3 plus 10 plus 3, side plus side plus side plus 3, side, and that is going to give me 26. That's the perimeter. When I want the area of a rectangle is L times B, so then I will say it is 10 times 3, and that will be 30. The units for perimeter is meters. The units for area, meters square. So this is the difference between perimeter, which gives you the line going around, or if you want to put an electrical wire with your loudspeakers or whatever in your room, that will be the perimeter. But the area, then you will lay a carpet in your room and you will need 30 square meters of carpet in your room. That is the difference between area and perimeter. There was also a question about a hypotenuse. What is a hypotenuse? Again, back to Mr. Pythagoras. If I have a triangle like this, and it is a right-angled triangle, that means I have one angle of 90 degrees, then this side is the hypotenuse. In Afrikaans praat ons van die skuinsy, but this one is the hypotenuse, the long side. These other two sides are the two short sides. So that is the hypotenuse of the triangle. And then there was also a question concerning the area and the perimeter of a trapezium. Now, when I give you a trapezium, you must first know what a trapezium looks like. This is a trapezium. Two of the sides are parallel. This side and this side is parallel. That means they stay the same distance apart. And we call this side A and this is side B. Now the perpendicular height is this height going down here. And it makes an angle of 90 degrees. That's why we used Pythagoras, because there's a triangle with 90 degrees, so Pythagoras can go there. Now when I want the perimeter, let's give this some distances. Let's say this is 10, this is 2, this is 15, and this one is 3. The perimeter will be side plus side plus side plus side. 10 plus 2 plus 15 plus 3, and the answer will be 30 meters. Again, perimeter is in meters. But the area of a perimeter is given by the formula half A plus B, the two parallel sides, times the perpendicular height. That red line that I had here, that line. And let's say this is, for instance, 1,5 or whatever you're going to use Pythagoras to do that. If they don't give it, then half, we rather use the decimal number for a half, 0,5 times, the A was 10, plus the B was 15, and the perpendicular height is that one. Let's presume it was 2 in this case, so then you will multiply it with 2. So this formula will be given to you, the area of the trapezium. Not the perimeter, that one you will have to do yourselves. But the area of the trapezium can be done by this. But there is also a different way of doing it. And it's by doing it like you eat an elephant. Ne? You can take the area of this triangle plus the area of the green rectangle, this one, plus the area of the blue triangle, and you will get exactly the same answer. So there are different ways of getting the area of a trapezium. The red one plus the green one plus the blue one. Or you can use this formula, half A plus B times H. I hope I have answered your questions. Now back to volume and surface area. Now you must remember, when we work with volume and surface area, we are working with three-dimensional objects. A cube, all the sides are the same, a rectangular prism, a cylinder, or the triangular prism. Now in the first question that they asked you, they said calculate the volume and the surface area of the following. Make a rough drawing of each shape that is described and indicate the dimensions. The first one is a cube with all sides 4,5. Now we're going to do the volume of a cube is L times L times L, and it's 4,5 times 4,5 times 4,5, and the answer will be 9 1,125, and we are working with millimeters there, so it's millimeters to the power of 3. Red light, I must round. 91,1, and this 5 is bigger than 4, so that's going to change that to a 3. Millimeters to the power of 3. It's a 3-dimensional cube. The answer is in millimeters to the power of 3. The surface area of this cube, can you remember? The net of the cube had 6 parts of the cube, and so it's 6L times L, and it is 6 times 4,5 times 4,5, and that gives me 121,5. Area is given by millimeters to the power of 2. That one is 3, this one is 2 because it is area. And now if you do a rough drawing of a cube, you try to keep all the sides the same length, and we try to do them 3-dimensional. Then I want to go on to the rectangular prism. To get the volume of a rectangular prism, we use the formula L times B or W or whatever, B times H, and now I see the tissue box is 22 centimeters long, so that's the L, 110 millimeters wide, red light. I cannot work with centimeters and millimeters. Red light. This must be converted to centimeters so that everything is in centimeters. Or you can take all of them to millimeters. It doesn't really matter because they didn't say which unit here. And when I go from millimeters to centimeters, can you remember that conversion table? Just look there. To go from millimeters to centimeters, we divide by 10. So it will be 11 centimeters. Another red light. 80 millimeters divided by 10 is 8 centimeters. So if I do the volume, it will be, the length is 22 times 11 times 8, and that gives me 1936 centimeters to the power of 3. Please take note, I did not use centimeters in there. It makes it very complicated. Leave it out there, but just see that you do write the units when you write the answer. Volume, 3-dimensional, so it's centimeters to the power of 3. When I do the surface area of the rectangular prism, it's L times, 2 times L times B plus 2 times L times H plus 2 times B times H. Now very often I see that learners make this also a multiplication. You start to multiply and you just multiply everything. Please make sure this is an addition sign and this is an addition sign. So it will be 2 times 22 times 11 plus, and I'll take a breath, 2 times 22 times 8 plus 2 times 11 times 8, and the answer there is 1012 centimeters to the power of 2. If I quickly do a drawing of the rectangular prism, try to keep your lines parallel. These lines must all be in the same direction, and these must be in the same direction, and those ones. That is a rough sketch of the rectangular prism. Now the cylindrical rod with 3 centimeter diameter and 1,2 meters long. Red light. I cannot work with centimeters and meters. Let's convert this one to 120 centimeters. Can you remember? to go from meters to centimeters. Century is 100 years. Is times 100, so it's 120 centimeters. The volume of the cylinder is given by the formula pi radius square times height. Pi again, 3,14 times the radius is 1,5 square times 120. And the answer there is 847,8 centimeters to the power of 3. Now, where did I get this 1,5? Can you see there was a red light there? Diameter is 3. So radius is 3 divided by 2, 1,5. Red lights all the way. So this shows me that we must be very careful when we read our questions. Don't rush through the question. If you see the word diameter, you must go to radius as well. If you see different units, take them all to the same. Then the surface area of this cylinder, a cylindrical rod is like a cylinder, is 2 pi radius, bracket radius plus height, and this formula will be given to you. Now we just do the substitution. The 2 and the pi, they are kissing. So it's 2 times 3,14, kissing the radius, which is, if you can remember, 1,5, bracket, radius again, 1,5 plus 120, and you read it into your calculator exactly like that. The answer will be 1144,53 centimeters to the power of 2. Volume, centimeters to the power of 3. Area, centimeters to the power of 2. And then a quick drawing of this will look more or less like this. When we do drawings like this, please write the measurements on the drawing. That was 120 centimeters, and this one, the diameter was 3 centimeters. I'm going to skip number 4. Let's go on to number 5. A rectangular concrete slab with a square base. The area of the base is 0,25 meters square and the height is 20 centimeters. Red light, meters and centimeters, we will have to convert. Now they say, give answers in cubic meters and square meters. So you can see that I will have to take this centimeters to meters. Let's do that before we start working on the sum. 20 centimeters, I must take it to meters. Now it's centimeters to meters, divide by 100, and that's going to be 0,2 meters. Now the volume of the concrete base will be the area of the base. That's the formula for the figure here, times the height. It's 0,25 times 0,2. It's that one. And that gives me 0,05 meters to the power of 3. Now there's something in this question that makes it a little bit difficult. It doesn't give us the measurements of the square base. They say the area of the square base, the area of this base is equal to 0,25. And we know that it is a square, so how do we get the area of a square? The area of the square is L times L, or then L square. So by multiplying the two, they got 0.25. I'm going to refer you back to the question. They said the area of the base, and it is a square base, is 0.25 meters square. So they have already multiplied the two lengths. And this is normally the kind of question that we get in paper 2. So you must be on the lookout, because now we have to change the subject of the formula. When we change the subject of the formula, it means that they give us actually the answer. We want to know how they got to the answer. Now, if I square the L, I get 0.25. Now I must do the opposite. The opposite of square is square root. So if I want the length, it will be the square root of 0.25, and the answer there is 0.5. So how did they get the area of that square base? They said 0.5 times 0.5, and it gave me 0.25. So now we know that I have this concrete slab that looks like this, and it has a square base. So this square was 0.5, and that was also 0.5. And they say that the height is 0.2. Now I have all the measurements that I need. I'm going to repeat. The area was 0.25 by multiplying L times L, which is L square, and the opposite of that is square root. And then when you get the square root of 0.25, I will get 0.5 meters in this case, and that will be the measurements. Now, when I want to calculate the surface area, I'm getting back to this question. It's going to be 2 times LB plus 2 times LH plus 2 times BH. Remember, those ones are kissing, so they are multiplying. 2 times the length of this slab. If I can just show you my picture again. Can you remember? It was 0.5, 0.5. So it will be 0.5 times 0.5. They are kissing. Plus 2 times 0.5 times 0.2 plus 2 times 0.5 times 0.2, and the answer there is 0.9 meters to the power of 2, because it is surface area. There's just one thing in general that I want to ask you. I've been marking the matric papers for very long, and we see that some people don't use the paper that was given to them. Please skip lines between your questions. It makes it very difficult when you don't skip lines. You have enough paper. The booklet that you will receive has 32 pages. Please make full use of that book. Start each question on a new page. If your book is full, please put up your hand and ask for another book. But you must make it easier for the people who are marking your papers. So when it's a long thing like this, use the space that was given to you when you do answer it, because it gets very confusing when we have to mark your papers. If possible, I want to skip exercise 2, number 1 again, and number 2 I want to skip. I want to go to the one with the glass and the breadth, because there's something very important that I want to tell you about this one. Calculate the volume of each of the following containers in liters if 1 liter is 1,000 cubic centimeters. Now you can see they are starting to work with capacity. But before you get to capacity, you must just do the volume. So let's start with the glass. To get the volume of this is a cylinder. You will have the formula. The volume is pi radius squared times height. Please remember, we only use pi when we work with circles. We don't have pi when it's rectangles and cubes. The pi is for the circle or the cylinders. Alright, pi is 3,14. The radius there, can you see that the diameter is 55 millimeters? And now we must go to centimeters. So let's convert that 55 millimeters first to centimeters. 55 millimeters, to go from millimeters to centimeters. Can you remember? Kilometers times 1,000 is meters times 100. Centimeters times 10 is millimeters. And you can even give those ones eyes and a smiley face if you want to. Alright, to go from millimeters to centimeters. Can you see? We divide by 10. So it's going to be 5,5 centimeters, which is the diameter. But I want the radius. So let's get the radius by dividing by 2. So the radius is going to be 2,75 centimeters. So now in the place of the radius, I use 2,75 centimeters. No, not centimeters. Square times the of this cylinder is 2,5, and the answer there is 296,828,125 centimeters to the power of 3. Red light. I cannot work with that. I must round it to 2 decimals. So it's 296,8. Now I look, what is after this 2 is a 8. So it will change that to a 3. So many cubic centimeters. But can you remember I said 1 cubic centimeter is equal to 1 milliliter. So what can I do? I use the same answer, 296,83 cubic centimeters is the same as 296,83 milliliters. Can you see the answer is exactly the same? This one is cubic centimeter and it's 1 milliliter. And now they ask you to convert it to liters. To go from milliliters to liter, you divide by 1,000 and the answer will be 0,29683 liters. If I want to convert that, around that, the 6 will make that 29 and 30, so it's 0,3 liters. So what did we do now? We had to convert that 55 millimeters to centimeters. Can you remember? Let's draw another face there. To go from millimeters to centimeter, backwards, you're going to divide by 10. So I'm going to divide that 55 by 10 and I get the diameter is 5,5. So the radius will be 2,75. So I did two things. I converted and I got the radius before I could start and just do the substitution. When I do the substitution, I have pi, the radius is 2,75 square, times the height is 12,5. Can you see I use no units in there? When I get the answer, I get the units. It's centimeters to the power of 3. Then I round it off. I changed from cubic centimeters to milliliters, and then I converted from milliliters to liters again. Quite a complicated question, this one. I would like to go on to the one with the rainwater. Now we're working with a cylinder. A cylinder has a base of a circle and it has height. There's a circle and then it also has height. Rainwater falling on the roof of a house can be harvested from the roof of a house into a water tank as shown. The tank in the picture has a diameter, red light, of 760 millimeters and a height of 1,84 meters. Red light. The one is millimeters, the one is meters. Please don't just fill in these numbers into your formula. You must first convert. You must first get the radius because they have given you the diameter. So let's start with the diameter. They want us to work in, or I want you to work in centimeters. Now to go from millimeters to centimeters, kilometers times 1,000 gives us meters times 100 gives us centimeters times 10 gives us millimeters. I hope you will write this down in your exam book. Then 760 millimeters, I want to take it to centimeters. Millimeters to centimeters, divide by 10. So it will be 76 centimeters. If I want, and this is the diameter, if I want the radius, 76 divided by 2, so the radius is going to be 38 centimeters. When I work with capacity, I always work with centimeters because I remember this. 1 cubic centimeter is 1 milliliter. It makes it a lot easier for me. Now the height is in meters. I want it in centimeters. How do I go from meters to centimeters? Can you see? I'm going to go in that direction. I multiply with 100. So 1,84 times 100 is 184 centimeters. And now, only now, I can get the formula. The volume of the tank is pi radius squared times height, 3,14 times the radius is 38. Can you remember that? 38 squared times the height is 184. There I have that one. Everything is in centimeters. So the answer is 834,285,44 cubic centimeters. So it is 834,000 of these things. So it's exactly the same as 834,285,44 milliliters. Can you see the same? And then you can convert it to liters by dividing by 1,000, and that is 834,285,44 liters. And then they asked us to round to the nearest liter, so it will be 834. Can you see? You cannot just take these things and put it into the formula and get the right answer. You must see the red lights. Diameter must be changed to radius. Millimeters and meters in one sum cannot work. You must convert to the same. Let's convert them all to centimeters, and then when I have cubic centimeters, I'm sure you will remember that this is 1 milliliter. I want to go on to the next exercise, the mixed context. They give us an industrial plot, and it has a length of 75 meters. That one is also 75 meters, that long part there. This is 60, and that one is 60. So the first thing that you must do is please write that in there. 75, that's 75, and this is also 60 meters and 60 meters. Now they say the owner wants to put up a fence on 3 sides. He only wants to put up the fence there, not here, as indicated below. Each panel of the fence is 1,5 meters long. There you can see that. And it consists of 1 vertical pole and 5 horizontal slabs. So what does a panel look like? One panel has 1 vertical pole like this, and it has 5 slabs. 1, 2, 3, 4, 5. So this is a panel. This whole thing is a panel. A panel. And this is a slab, and slab, 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 and that is one pole. And this is 1,5 meters, like that. All right, now the first question there, and please keep this next to you so that you can just refer back to the sketch. The total length of the fence. If you look at the picture, you will see it's going to be 60 plus 75 plus 60, and the total is 195 meters. 60 plus 75 plus 60 is 195. And now they say calculate the number of slabs needed. When we have a word problem like that, we only have 4 calculations that we can do. We can either plus, minus, multiply or divide. So you must decide, what am I going to do now? I must calculate the number of slabs needed. I have the full distance is 195 and one slab is 1,5 meters. Now what am I going to do? I cannot add the two. I cannot subtract it. I cannot multiply it, but I'm going to divide that 195 meters into 1,5 meter slabs. So the calculation that you're going to do is division. And then you get the answer. You will need 130 panels. But now, how many slabs will you need? If you look at the panel, the whole panel looks like this. One panel has 5 slabs. So 130 panels will have 130, not plus 5, not minus 5, but multiply 5. And that will give us 650 slabs that you will need for the whole length of that fencing that he wants to put around. So I added up the sides, then divided it into the 1,5 meters for 130 panels of these panels, and then I will need 130 times 5. I will need 650 slabs. Now what is the cost of this fence? It will cost 250 rand for one panel, and then we will need how many panels? Can you see? I will need 130 panels times the price, which is 250, and the answer there is 32,500 rand that this fencing will cost. Well, thank you very much for listening to me. I hope you all understood very well what we did today. Bye-bye.